Okay, well, welcome everyone to this meeting of the virtual CICS user group. As you can see on that slide in front of you, our new website address, if you haven't found it already, is at itech-ed.com/virtual CICS. So let me introduce myself. I'm Trevor Eddles. I'm CEO of iTech Ed Limited. We're a mainframe consultancy, analysis and technical authoring organization. And we're the people responsible for the content of the virtual CICS website. And we produce the newsletters as well. So like I said, the website can be found at itech-ed.com/virtual CICS. So let's start by running through the agenda for today. And as usual, most of the meeting will be taken up with a presentation. And today our guest presenter is Russ Teubner, who was CEO at HostBridge Technology, but is now a distinguished engineer in the mainframe software division at Broadcom. And he's going to be discussing using analytics and AI to find and fix inefficient patterns in CICS integration. And with him today, we've got Greg Smith, who's a software engineer. So he'll be joining in at some stage as well. Just so you know, a copy of the slides from this presentation will be on the website later today. And if you missed our previous meetings, you can download copies of those presentations from our website. And you can also listen again to the whole presentation. The link's on the resources page of our website. So that's itech-ed.com/virtual CICS/resources.htm. Following Russ's presentation and any questions you have for him, we'll move on to the latest CICS news and the latest CICS related articles. And then I'll give you the dates and times for the next virtual meetings. So that's the plan for this meeting. And I'm anticipating that it will last for just under an hour. Just admitting some more people. Okay, so as I just said, today's presentation is from Russ Teubner. Russell Teubner is a distinguished engineer at Broadcom, focusing on mainframe application modernization. He's a seasoned inventor and entrepreneur with over 40 years applying his creative energies to solving difficult problems associated with integrating IBM mainframes and emerging technologies. His full CV that he's given me is much longer than that. So if you want to read more of it, it is on the website. But he is an absolute whiz at CICS and lots of other things. So Russ, what I'd like to do is thank you very much for being with us today. And let me stop sharing my screen and you can share yours and get on with the presentation.
Okay, thank you very much, Trevor. Yeah, I love that phrase, seasoned entrepreneur or inventor, whatever it was. Every time I hear that, I just feel old. That's what that means, getting old. Well, thank you, first of all, Trevor, for the opportunity for Greg and I to be here today to discuss a topic that we really love. We've been working on this product for a few years now, and it's just been a wonderful ride. And we're going to explore a topic that we call integration analytics. And we're going to define what that means. And particularly, we're going to talk about a couple of use cases within CICS where we've really started to work with some customers on. As Trevor indicated, it was only like about 45 days ago that I was the CEO of HostBridge Technology. Now, of course, with the acquisition by Broadcom, both Greg and I, and in fact, our entire technical team at HostBridge made the transition. And so now we are part of Broadcom. So in fact, this is one of my first public presentations on this topic now as part of the Broadcom organization. So it's a pleasure to be here. We're going to move through very quickly. This is what the agenda is. And we've got a lot of content here. And so please feel free to consider questions, type them in. We're going to allow some time at the end, but we're going to try to get as much information on the table. And we are, just full disclosure, we're going to talk about a product that we developed at HostBridge, and now it's part of Broadcom. And yes, we're going to talk about a product, but this presentation is really about a problem, a situation that you may be encountering within your organization. So although we're going to use our product to actually show the problem, we really want to invite you to consider this much more generically. It's just that in order to see the problem, we need to use our product as the microscope to really document and understand what's happening. So that is roughly our presentation. The bios have been rendered or have been given. So again, it's my pleasure to have Greg Smith with me today. Greg was there from day one as we were developing the integration analytics platform. I learned very quickly that I needed to have an analytics, particularly a Splunk subject matter expert right at my wing, and that became Greg. And from there, we began to develop this technology out for our customers. Let me first of all address kind of a very generic question, and that is why? What is this thing called integration analytics? Because I'll be honest, I sort of made that word up. I didn't know quite what to call this. And so since we're trying to look at patterns of integration to the mainframe, and particularly with CICS applications, we want to do deep analysis on that. I don't know. I just decided to call it integration analytics, and the rest is history. But here's our view, and that is that inefficient integrations are a significant barrier to modernization. Now, I'm not going to go over at this level all of these various patterns of integration. We're going to focus on one, but no doubt your mainframe environment roughly approximates this as well. You've got this ever-growing list of stuff on the left side of such a diagram across either your organization or coming in from the cloud or coming in from customers. You're going through various channels of interaction, whether they are TN3270 or app servers or whatever they may be. But what we have developed is a strong opinion that inefficient integrations are not only a barrier to modernization, but they also cause all sorts of inefficiencies that frankly give System Z and very good and valuable CICS applications sometimes a black eye. Those inefficient integrations can inject latency that can degrade quality of service. They can even add transactional load. We're going to show you a use case of that. Bottom line is they end up wasting MIPS. They compromise ROI. They make it difficult to modernize the app. And as I said, we believe that inefficient patterns of integration create a bias against the mainframe. And it's something that we're very passionate about helping our customers resolve. Now, inefficient integration surfaces in different ways at different companies. Now, this diagram is very simple, but it actually comes from a real life conversation with a customer. A Fortune 100 or the global head of IT, a mainframe customer for a Fortune 100 customer called me one day a number of years ago and said, "Hey, Russ, I got a problem." Now, full disclosure, if you want to make my day, that's how you do it. So he said, "I got a problem." And it's like, "Pat, talk to me." He said, "Well, our business is growing nicely, but we've hit some sort of I don't know if he came up with this term or I did, this wall of inefficiency where something has happened. And now our mainframe transaction volume is going up, the overhead is going up, something is going on asymmetric to the underlying business activity, and we're having a hard time seeing it. We have some ideas about what might be happening, but we can't prove it." Well, that was enough to get us started and trying to figure out, could we really do that? Could we reveal enough information? And so that really led us to develop what we now call HTAC. Now, originally, those four letters stood for something. They don't really matter anymore. We just call it HTAC. But it is a diagnostic platform designed to help organizations find and analyze inefficient patterns of CICS integration. And again, that's our short form phrase of saying that is integration analytics. But we have various objectives. We want to find the common and wasteful patterns. We want to quantify their impact. We want to reveal the business process. And this is sort of a big deal for us. We want to show you the DNA of the integration. And then we want to make sure that we provide actionable intelligence that lets you know how to solve, what problems do you solve first? Many organizations believe that they have to boil the ocean or solve all the problems to see benefit. Based upon the data, nothing could be further from the truth. If you, on average, if you handle your worst 5 to 8, maybe no more than 10 patterns of integration, you will see significant business and operational benefit. Now, we decided to solve this problem by creating a framework, and I'm going to go through this very quickly. And all of this is really just preparation so I can actually show you some real data. But again, there's the diagram that we sort of started with a few slides ago. And the storyline here is very simple. Large organizations, no doubt those of you on this call, you probably have good technology to be able to understand and see what's going on within those two brackets on the left. You probably also have some good technology to look at what's going on in your network and kind of your boundaries and edge connectors. And no doubt you have really good technology to do a deep dive within the mainframe and the operational aspects that are going on there. But here's the problem. There are very few tools that let you look at this holistically. So in other words, most organizations do a really good job optimizing within each one of those silos. But if they're not careful, they miss the big picture. And they end up, as a result, committing more mainframe resources to support their business processes than they really need to. So what we decided to do was to create a framework. And this framework is very simple. It has 3 cornerstones. One is the idea of enrichment. Enrichment is very simply, we provide a set of CICS exits that gather little bits of metadata about each and every targeted request. With that metadata, we enrich the CICS monitor data in the origin adapter fields, so we don't add fields. And then that, of course, flows directly into the SMF 110s. Now, then we transport that down to a proper analytics platform like Splunk. A legitimate question at this point is why Splunk? And it's very simple. On the day I had to make a go or no-go decision, I called 5 customers and said, what do you have? They all said Splunk. So right now we're focused on Splunk, but we get it. There are other analytics platforms that your organizations may care about, and we're looking into that actively. But the framework here is to enrich, to transport, and then analyze. And we're going to show you what that looks like. I'm not going to belabor this chart, but it'll be in the slide deck that just gives you a little more insight as to what exactly we're doing at each one of those steps. I did mention these CICS exits, and while I won't belabor it, I do just want to put a note here that says these are very efficient exits that are gathering little bits of metadata. They're designed to be run 7 by 24 by 365 or on demand. Some customers run them all the time, some customers don't. It really doesn't matter. And full disclosure, they are actually optional. We can do a fair amount of analytics without them, but some of the rich details that we're going to show you in our DNA analysis require these exits, or at least a few of them, to gather some data. Now, let me go ahead and give you a bit of an overview on another component. So when we talk about HTAC, we think of it as a very generic platform that can be applied to different problems associated with integration. However, we started working with different customers, and at every one of them, they had one style of inefficient integration that just kept popping up. And it was this. It was client, server, or cloud-based programs or tools running off the mainframe that were automating the execution of screen-oriented CICS transactions. Yes, indeed, it may be 2022, but in many organizations, terminal emulation and screen scraping continues to be an incredibly entrenched methodology for application integration. Now, there are a number of examples that we can all think of. I've listed a few, terminal emulators that have scripts or macros that automate activities. There are a lot of organizations that use Excel macros with embedded VBA scripts. Products like IBM Hats, we're not picking on hats, but it's a very prominent product out there. It has this whole macro automation capability. And then certainly this whole new genre of products, the RPA platforms, the robotic process automation tools, they are single-handedly, and this is not a good thing, but they are single-handedly causing a resurgence of terminal emulation and screen scraping as a method of integration. And as System Z professionals, you need to know that, and you need to be able to start getting prepared to see with tools for how to detect that and manage it. Now, to be sure, sometimes using emulation and screen scraping as a means of integration is just harmless. It's no big deal. But sometimes it's extremely harmful and extremely wasteful, and we're going to show you those examples. Now, a lot of times someone might ask the question, well, why is such automation problematic? Why is it that an endpoint on the left, why is it that it's a problem for an endpoint on the left to be able to interact with CICS applications, dozens, hundreds, or thousands of interactions back and forth? Why is that a problem? Well, it's probably beyond the scope maybe of this particular webcast, but let's net it out like this. First of all, it causes very high latency. Secondly, it elevates or increases overhead. All those requests are passing through a lot of componentry. And then lastly, as we'll see, poorly written bots and macros and scripts can actually cause higher CICS transaction volumes. And we're going to show you a use case where that's exactly the case. So what is Macro Hunter? Well, just to continue, what we did was we added a set of features both to the CICS exits as well as to the Splunk dashboards to be able to really hone in on this problem of sources of things outside the mainframe that are automating CICS screen-oriented transactions. Now, before we dive in, let me just do a little vocabulary dump here, where there are a number of terms and concepts that we throw around very quickly, and I just want to define them here. First of all, when we use the term macro, RPA, bot, or script, we're really kind of using those interchangeably to describe something, a program or a tool that is automating the execution of screen-oriented CICS transactions. Macro Hunter, our code, our product, we don't care about what the source of the automation is. Frankly, analytically, they all look the same. Now, we also talk about DNA of a bot or a macro or a script. The DNA in our terminology is the sequence of steps it performs, and we'll show you examples of this. Now, these DNA sequences can be long, and so what we do is we generate what we call a signature. And a signature of a DNA of a macro is nothing more than the DNA expressed as an MD5 hash value. So for example, that long hexadecimal number there, that represents a particular instance of a bot or an activity. That represents the DNA. That is its signature. Now, it doesn't matter that it's kind of gibberish there, a big long list of numbers, because graphically you'll be able to see exactly what the problems are. Now, in some of our slides, you're going to notice that for convenience, we refer to certain signatures by their first 4 characters. So there's a chart a little bit later that says something like 3C64. That's just our little shorthand for signature. Now, again, each DNA signature has a unique identifier, and it's by creating that unique identifier that allows us to hunt, as we say, for the most common problematic cases during an operational day, week, month, or year. So you can know what really are the most impactful problems. Now, we're going to, in some of the slides in the demonstration, you're going to see Splunk dashboards that have a bunch of data that looks like this. And so just again, to kind of get you prepared for what you're about to see, let me walk through this very quickly. First of all, when you see a little bit of analytics or analytics dashboard that looks like this, each of these columns has a meaning. So for example, RPA total, that is the total number of transactions that were executed as part of that particular RPA. So someone fired up a script, a macro, a bot, something that ran 10,503 transactions. Now, the duration from the beginning of the first transaction to the end of the last transaction took 22 minutes and 30 seconds. That's a long time. Now, this is another interesting statistic to compare it to. This is actually the duration of the individual transactions. So those 10,503 transactions themselves only took 1 minute and 33 seconds to run. So why did the entire macro take 22 minutes? Well, it turns out that is latency for the most part, and it's also operational delays imposed by the tool, the macro, the bot, whatever you're using outside the mainframe. Now, to see this impact, we compute what we call the duration ratio. And so the higher the ratio, when you're scanning these things, it represents probably the greatest opportunity for being able to make a macro or a business process more efficient, at least from a real-time standpoint. Now, of course, we also want to keep track of the total CPU time. So those 10,503 transactions actually consumed 27 seconds of CPU. And on some of our panels, we'll actually convert that to MIPS if we know your make and model of your System Z hardware. We also do a rough calculation of transactions per second. We also give you kind of a statistics. This is a very simple example where all it did was it ran the ORR transaction 10,503 times. And then the DNA column is where we want to guide your attention. The way you decode that as you read that is that says that what this macro did was it ran the ORR transaction, pressing the enter key back to back 10,503 times. Now, again, we show the DNA like this for a purpose so that we can then, a subject matter expert with the application can then look at that and go, huh, I wonder what they're doing. Well, when we showed this to the SME for the application, and then they called the end user, it turned out that what this organization had done is they had written a macro that pressed the enter key roughly every 200 milliseconds until the status of an order changed from pending to fulfill. That's all this macro is doing. And to do that though, the implementation of that status change was, what was it? It ran 10,000 CICS transactions. Now, I think we can all agree that there are better ways to architect that sort of a notification back to an agent or a salesperson or an order processing person. But again, given what we like to say, you can't fix what you can't see. And so the purpose of this tool is to help you see what's actually going on under the covers and what's really driving transaction volume. Now, I just want to reinforce with this slide one more time that the DNA is the treasure. That's what we're hunting for. Now, the DNA can be much more complicated, like what you see here. And I'm not going to go through all of this. But again, you'll have it in the slides to let you know that, again, what we're trying to denote here is that every single step in the robotic process that someone coded. So in this case, that's what we've highlighted here, is that at this step, a transaction called PBSE was run in a AOR called CIA4, and it was started by the enter key being pressed. That little greater than arrow indicates that the output of that program, or the output of the transaction, came from programs CM1, 0, P003, and it displayed a BMS map where the map set and the map name are the same as CM10MO3, and that *2 at the end says that occurred back to back. Now you're going to see these DNA examples pop up, but again, what I want you to see is that they range from the simple and absurd, like someone pressing the enter key 10,000 times, to a very complicated business process. It turns out this is a real significant business process in that organization. And it turns out that that is, at least given the current application structure, that's the right way to solve the problem. But it's important for organizations to be able to see what's really going on. Now, with that, I'm going to pause for a minute. And Greg, why don't you give us a peek behind the scenes before we dive into the demo?
Thank you, Russ. Hi, I'm Greg Smith. I've been fortunate enough to be one of the primary developers of this Macro Hunter tool, and I've been the customer engagement lead for Macro Hunter for a while. So I'm here to demonstrate some of the diagnostic capabilities of our Macro Hunter dashboard. So next. But first I want to take you to a very brief background. So this journey of this Macro Hunter product really began when we were listening to our customers and then understood their needs. But then we had to merge their requirements with ours. Their main requirement was to find the RPAs within a huge data ball each day. And one client, they had 31 million events within a 24-hour period. And that equated to like 58 gigabytes of data being transported from the mainframe into Splunk. But our main requirement was really to process a large time expanse through this DNA algorithm shown here, and in order to properly detect and to define the RPAs. So we had to design a multi-stage Splunk architecture and the code that goes with it in order to process and visualize huge data sets and over large time expanses. But the whole process yielded a product that's both robust, it's scalable, it has excellent performance, and it provides intuitive metrics. But one thing that I just want you to know is that whole Macro Hunter process is autonomous to the user. It all occurs behind the scenes, and really what the end user interfaces with is the dashboard, which you'll see on the far right of that diagram. So now we're going to dive into the actual dashboard itself. So the first thing you really need to know about the dashboard is that the data represented in all these graphics have already been processed through the DNA algorithm. And that is to mean that this is not viewing the raw mainframe data. Instead, these graphics all represent statistics that have been calculated from the results of that DNA algorithm. Now, this is just a snapshot of the top 4 rows of the dashboard. And the purpose of it is to just highlight that each of these rows really has a very specific diagnostic capability. And I'll go into more details on the next few slides. So let's start with the menu. So we were dealing with a wide variety of clients, and each one had different needs. And so we designed this menu system as really the first filtering mechanism for this huge data ball of data. And so you notice there's a time frame that you can choose, and that's not for the processing, that's just for the visualization on the dashboard, because all the data has already been processed by the time it reaches the dashboard. So, but you can also filter by what we call a CICS environment, which is nothing more than a group of user-defined OAPL IDs. But it also allows you to filter down to specific users or endpoints, which is a net UOWPX, or it could be a client IP address. So also there's one other thing is there's a large amount of panels on the dashboard, and we also allow you to actually turn on and off those dashboards just so you're not overwhelmed. So next. Okay, so this set of visualizations was really designed to allow a client to correlate between their operational issues and RPA activities actually occurring on their mainframe. So using other monitoring tools, a client would note the day and the time of their operational issues, and then they would use the Macro Hunter dashboard to assess whether RPAs were active during that time frame. And if they were, which macros were being executed. So just for reference and reading this chart, the numbers on the top of each of the bars represents the total RPA execution started during that time span. Now let's see what happens when you click on one of those minute bars on the far right. So you see a chart like what Russ discussed before with a lot of different parameters. And so since the minute chart really only showed you total quantity, when you click on that, it provides you a listing of all the RPAs associated with that minute. The bar that was clicked on was 181. So this is only the first of 181 macros that are represented with all their statistics associated with it. And you can sort the table through any field, or you can just scroll to find the results. So next slide. So this is one of the more important slides. So these bubble charts were designed to help a client understand that even though you may have thousands of RPAs, bots, or macros running on your system, you really don't have to address all of them to see significant improvement in your mainframe performance. So these particular charts rate your CPU time, which equates to cost, and then your RPA total duration, which partially equates to quality of service. But it also gives you, with the size of the bubble, the quantity of executions. So these particular categories were chosen because the various clients wanted to know who is executing the RPAs, where did that RPA come from, and then what RPAs were executed, and really how many were being executed during the time frame selected by the menu. So what I'd like to do next on the next few slides is go through a quick diagnostic, and you'll see even in this slide, the 614E and the AF66. And again, that's just the first 4 characters of the 16-digit signature. So you'll notice in this chart, now the title of this chart deals with total signature executions. So that you can see that the 614E RPA was executed 1,803 times, which is really like 3x of its nearest competitor. But you'll see the AF66 is actually 4th on the list. Now, the AF66 in the bubble chart was actually the highest as far as CPU time. So even though it may look insignificant here, it's not. Now, kind of how you read this particular chart, these Pareto charts, which are just sorted bar charts, how you read this is there's only 10 shown on each Pareto chart, but you'll see up in the title, there's actually 3,160 not shown. So even though there's only 10, if you look at the small line there in the graph, it culminates in 30 or 30%. So 30% of all the macros are being run for those menu selections actually represent, was 30% of all the macros being run on your system. So if you mitigate just those 10, you've had a significant blow against your mainframe resources. So let's go on to the next slide. So now when we compare those same RPAs on the CPU time, we'll see that just like the bubble chart showed, AF66 is the top contender, whereas 614E is actually 4th on the list. And so you can see though that these 10 RPAs though deal with 42% of all the RPA CPU execution times. So almost half of all of your RPAs, even though there's roughly 3,200 RPAs being run for this data set, 42% of them are accounted for by only these 10 RPAs. So again, to reiterate, you don't have to boil the ocean to have significant impact. So I have one more slide that I want to deal with, and this one deals with the total duration. Now, the bubble charts were sorted by CPU time because that was really, since that relates to cost, that's really the biggest contender. And so, but you see that the largest one from a duration viewpoint was 614E. AF66 took up the most CPU time, but the total duration is actually wasn't even on the former charts. It's this OE53, and it's almost double of what the others are. So when you're deciding which RPAs to mitigate, you really have to understand what problem you're trying to solve. Are you trying to reduce cost by reducing the CPU execution times? Or are you wanting to improve your quality of service and therefore the total duration? So each of these rows that I've been over deal with a different method of diagnosing and selecting which macros and RPAs that you actually want to mitigate through. And there's a variety of methods which we won't go into in this presentation, but Broadcom through HostBridge technology has means to rapidly mitigate these issues. So Russ, at that, I'll turn it back over to you.
Okay, great. Thanks, Greg. Again, everything that you just saw that Greg walked you through will be background information because we're going to go live now. I will tempt fate here and seek to do a live demo. So let's go over to a browser and let's go ahead and refresh it. See, just to confirm, Greg, is the Splunk dashboard coming up? Oh, you guys, are we good?
Yes, it is.
Okay, great. Okay, we are live on one of our Splunk instances. We're looking at some sample data. This is a very small bit of data. And you can see that I'm going to go ahead and just click a few options. I'm going to say I do want to display the Paretos. I do want to display the top RPAs just to see it. I'm going to display just one in the table. I want to see what is the longest RPA. But then I'm going to come, so let's go ahead and say submit. And let's go ahead and get this data. So here we have it. Now, again, this is just sample data from March in 2021 at a particular site. And during this small window of time, we detected over 5,000 RPAs that invoked or caused about 123,000 transactions to be run. Now, as Greg illustrated, I can click on this to drill down. Now, this is, again, a very small window of time. So I can go from the day, I can look per hour, and again, I can look for minute. And this, as Greg alluded to, this presentation of the data, be able to drill down to the minute level and then click on a minute bar, that was inspired by a customer who was very concerned that RPA and macro activity was actually causing a lot of significant service degradation on their system. And so they wanted to be able to correlate it down to the minute level. And so that's why we did that. But let's scroll down just a little bit. Here are the bubble charts that Greg alluded to and described. Now, already, I mean, we've been on this screen for what, 2 minutes? And already I know a wealth of information. Look right here. It's clear that there are 2 IP addresses that are driving the bulk of the RPA activity against CICS, something at 10.1, 63.79, and 78. And also, if you look over here, resources per signature, I mean, there's just no doubt there is a clear winner, isn't there? And that is that there is one particular DNA, there's one particular bot that has the highest, that is both the highest in terms of CPU time consumption, as well as the longest or the highest in terms of total duration. Now let's just, so it won't be hard to figure out once we click on that bubble. But now we can go down to the signature analysis and look at the Paretos. Now, whereas if you look over here at the user ID Pareto, they're fairly, dispersed. And this is also something we see a lot of, and that is there are 8 user IDs that that account for 80% of all activity. Now, it turns out a couple of them are generic, but those that aren't, it's always interesting to see who's really driving the workload. Here in this bar chart, we can see clearly there are 2 IP addresses from which the bulk of the workload is coming. And in fact, here's another representation of the fact that we have, there is one particular signature that is 80% of, represents 80% of all RPA activity. Now you can continue to scroll down. You can look at it from both a real-time standpoint. You can look at it from a CPU time standpoint, as Greg was alluding to. Now, while I'm here, let's go ahead and for the sake of time, let's just jump right in. I'm going to go ahead and click on that bubble and find out what is the most expensive macro or bot running on this system. Well, there it is. Now, again, we do some fairly sophisticated analytics here in order to be able to deduce the DNA of these sequences of activity, find their beginning, find their end, or look for their common parts, and then represent them with a common signature. And so what we've been able to say is this particular signature is the most common signature. And we're gonna look at this in a minute. But we can also sort on RPA total column, and we can say, well, sometimes that particular signature is entangled with 105 transactions, drives about 105 transactions. Then as a low, it's about 15. Turns out that the average is about 18. Now, the reason we show the DNA the way we do is so that we or you, a subject matter expert, can look at this DNA and maybe have an aha moment and ask some good questions. Now, I'm going to drill down and look at this DNA because this DNA, when I saw this, it really caught my attention. So let's begin to look at kind of evidence of what makes a bad bot, as we say. So now here is the DNA that we saw at this real, in this real world example. And there it is. The transaction is called GIMS, and you can see the interactions and the BMS map set and map names. And the subject matter expert looked at that and said, okay, I mean, they know this application extremely well, and they can say, well, I guess I can figure out what they're doing. But when I looked at this, it was like, look at that line, these lines that say dims plus clear, and dims plus then a clear key back to back. And the moral of this story is sometimes it takes a curious human to spot a bad bot. And so those of us who've lived in the CICS world all our lives know that it is not uncommon for the clear key to be used to exit a particular application or transaction and get back to a clear screen and then enter another transaction. Which begs the question, why would you do it 2 times in a row? That's kind of odd. So why is it used so frequently? And why is it used back to back? Well, let's look at that. So we ended up calling the customer and said, something's weird here. And we said, what are these endpoints? What is that .78 and .79 on your network? And it turned out that it was 2 very large servers running IBM HATS, Host Application Transformation Server. And it turned out that the bot or the macro, really in HATS terms, that we detected was really implemented by a main macro, which invoked 5 smaller macros. So again, if we look at that DNA now and we break apart that repeating clear key, we can see what each of those 5 macros were doing. Now, here's where it gets kind of interesting. And I suppose you can understand how people of good software developers might have ended up doing this. But each of these subroutine macros was written to be a good citizen or a good macro. And they were also written to defend against bad citizens or bad macros. So what did they do? The first operation of every macro is to clear the screen to get it into a known state. The last operation of every macro is to clear the screen, leaving it in a known state. And they do that even if they only run one transaction. Now, the macro authors did this with the best of intentions. However, the unintended consequences were significant and severe. It turned out when the application subject matter expert looked at this, their first comment was, they don't need to use the clear key at all because there's a field on the screen that lets them enter the name of the next transaction to be executed. And so as we as we began to kind of unwrap this and look at how this all happened and did the math, it turned out that 50%, and that's, I'm not making that up, 50% of all transactions being driven by hats in this example had no functional or business value. Let me say that again. 50% of their transaction load had no functional or business value. It was a pure waste of mainframe time and end user, and caused a significant amount of end user delay, because every time the user was waiting for a response from hats, all of this activity was going back and forth to CICS. So we would bring this up, or we would offer this as an example of what we would refer to as a very bad bot. Now, it's not the only kind out there. I mean, there are lots of different use cases out there. But nonetheless, the objective of the Macro Hunter tool is to help organizations see what's going on, see the forest for the trees, and optimize the whole process. Now, let's begin to close here and move toward Q&A. We've certainly outlined that the HTAC framework is generic, and it's intended to be applied to many different problems associated with integration. Based upon our work with customers, we happened to really focus heavily on this one use case of interacting, of things outside the mainframe, doing automated interactions with screen-oriented transactions. But the same problems or similar problems occur in much different contexts. So for example, we worked with one customer where they had a Java-based application communicating to CICS via a proprietary socket protocol. And again, it was one of these situations where they could not see what was really happening, what was really, and the business value of all of these interactions. Another customer we worked with had a large, significant .NET application running on a bank of servers. And what they were doing is sending in just a torrent of individual discrete HTTP requests and getting back responses from CICS. And so they needed to be able to see what was happening there so they could optimize that. We're also looking at other use cases or evaluating them. One in particular that kind of piques my curiosity these days deals with z/OS Connect. z/OS Connect is a great product. But in a CICS environment, what it does is it creates an API around one or a single CICS program. Now, and if the business process requires the execution of multiple programs, well, usually what happens is something outside the mainframe starts to automate that activity to the mainframe. So you get this torrent of HTTP or API requests coming in to z/OS Connect, and then firing up mirror transactions to run the actual CICS workload. Again, a pattern of integration, very different than emulation and screen scraping, to be sure, but a pattern of integration that at least needs to be seen and observed so you can determine whether or not it needs to be addressed. All in all, what we'd say is we're really excited about this particular platform. We think we've only scratched the surface, so we would love to hear from you about your integration challenges that you may face. With that, there's our contact information. And Trevor, I will yield back to you for some Q&A if there is any.
Okay, thank you very much. Yeah, if anyone wants to type in their questions into the chat, we'll let Russ and Greg give us their best answers. We'll give people a few moments to do that.
I might just say, as people are considering questions, we get it that there are some organizations that have done a really good job of re-engineering their CICS apps long ago to separate presentation logic and business logic. Well done. However, there are a lot of organizations that really didn't make that turn. And Macro Hunter is specifically tuned for those organizations. But even those who have separated business from presentation logic, chances are there's also a lot of different types of integration coming into your CICS environment that might equally deserve scrutiny.
Okay, we don't seem to have any questions coming in. Let's just wait another moment or two.
Well, either we were that clear, or it was clear as mud. I don't know.
No, I thought that was really interesting. And I mean, I think you're right. There are still a lot of sites out there that are facing the same problem. It's all automated, but they don't know quite where the automation is going wrong, as it were.
Yeah, and again, Greg and I can't reiterate enough that you don't have to boil the ocean. You do not have to solve every potential problem. You just have to find and fix the ones that are really impactful, and that's all the tool is meant to do. Show you the bad bots.
Okay.
Hi, Russ, can you hear me?
I can.
Oh, good. So I'm sorry, I didn't see a place to enter a question via chat, so I thought I would just ask. On the selection of the DNA fields, the train ID, the region ID, the enter key, etc., are those modifiable? Can you say I want to collect, I want to ignore the terminal, the PF key, etc.? And then when is that signature created, right? So is that, if you change that, can you reapply it against the data, or do you have to re-record everything? And like, can you look at the data and say, oh, now let's maybe get rid of that, it's extraneous and it's skewing the data. Let's eliminate this, and etc.
Yeah, that's a great question, Mike. Currently in the product, what you do is you enable this metadata, like the PF keys and the BMS map information. That's actually part of the metadata that we're mining using our CICS exits, right? And so then it goes into the CICS monitor data fields, usually OA data 1, 2, or 3 in a particular syntax, and then it gets into the SMF data and comes down. Now, once that data hits Splunk, that's when we make the decision about what to include in the DNA. So, for example, in this case showing on the screen, we included the transaction ID, the AID, and then the BMS map set and map name, and not the sending program. The BMS map and map name is optional. We could take that off. The only reason we needed to use it for this customer is the transaction name is always the same. And so just saying DIMS clear, DIMS enter yielded no insight as to the navigation path through the application. Now, to your question, the DNA is formulated down at the Splunk level. And so and then the signature is derived from the DNA. So at this time, that's a one-time thing. Now, and to go back and rerun and kind of reset the DNA or recalculate it to include more or less detail, and then redo the MD5 hash would be pretty time-consuming and expensive on the Splunk platform. So our solution to that, however, is to allow you, what we're working on right now are ways to let you be able to create multiple signatures. In other words, maybe you want to have DNA, version 1, or a DNA and a signature that includes BMS map and map set name. Or maybe you want to have another one that doesn't, right? So you can have alternate signatures. And so that's probably where we're headed. And it's really just a matter of computational efficiency.
All right, good. So easier to just rerun and recollect the data than it would be to change it after it's gone into Splunk.
Yeah, once it's in Splunk, it's really hardened. And now we can't, it's not to say we can't regenerate the DNA, because that actually, it's a two-step process. We ingest the data, and then we go through DNA analysis, and we put the results in a Splunk secondary index. So we could rerun that and shape the DNA per your specifications. But again, our thinking is that operationally, we might just do it in one pass and just let you pick, well, you'd like to have 2 or 3 different forms of DNA. But yeah, you can always rerun and re-ingest. That's
And then multiple regions. So typically we have a TOR and might spread it out to a set of clone AOR. So including the AOR region name might make it confusing, because it would be a different signature each time and wouldn't match up, right? How do you handle, or do you handle, what happens when something goes across multiple regions?
It's a good question. Let me bring up this slide, because that kind of illustrates the process, right?
That's what I was thinking about, this slide here about the region.
PBSE,
All right, go ahead.
Yeah, it goes to CIA4, and clearly in a complicated environment, that might be, let's envision that there are 4 different AOR CIA 1 through 4. Well, in that case, yeah, you might not want to include that, because you're right, it would get a different signature. However, we can play some games like that. Just because we show you the full DNA like this, we're not necessarily, we don't have to generate the MD5, including all bits of information. For example, I'd have to go back and look. Right now, I don't think we're actually generating the MD5 based upon that, the AOR. So that CIA4 would not be included. Although it could be. But again, to your point, what we need to, we're taking our cues from our customers, honestly, in order to figure out, okay, what is the most helpful? And as you said, in a complex environment, if the signature ends up being based upon the target AOR and it's one of many, it can be misleading.
All right, thank you, Russ.
Sure.
Okay, we've got a question from Dina Deutsch, who's saying, what is the input that is being used?
Oh, very good question. Let me go all the way back to this. Let's use this diagram, or let's use this one. And let me go ahead and just lay in that graphic. So the input, the starting point of the analysis, is your SMF 110 data. And that has likely been enriched with a little bit of this metadata about the transactions and the context in which the transaction ran. Once that, then we take that SMF data and we cause each SMF 110 record to be translated into a JSON document that is then transported to Splunk. So the input to Splunk, the input of the analysis, are a large collection of JSON documents, each of which expresses some level of detail or fields from SMF 110 records. Once the JSON documents are ingested into Splunk, then the process that Greg outlined, this one illustrated on this chart, begins. So we do the extract and the enrichment. We transport it down. And by the way, customers use many different techniques to transport it down, from FTP to we provide a real-time emitter to a variety of products. Transport is not the secret sauce here. It's really extracting and enriching the metadata and then doing the analytics under Splunk. So we bring it into a primary index. Then we do the DNA algorithm. Then we create what we call a summary index. And so the input to your question, I guess, is enriched SMF 110 data that has been expressed in the form of a JSON document for each 110.
Okay, brilliant. Thank you. Yeah, I think that's all the questions we've got. So if anyone has any further questions, you can email them to me and I'll email them on to Russ or Greg. And I'm sure they'll get back to you fairly promptly with an answer. So yeah, can I thank you, Russ and Greg, for your presentation? That was really interesting. Yes, a good solution to a problem lots of people are facing, I'm sure. And as I always say, because we're a virtual user group, please assume you're getting a virtual round of applause at this moment. So thank you very much.
Thank you.
Okay, let me just share my screen and we'll finish off. So yes, news. I actually haven't received any CICS related news, so I haven't got any to share with you, but articles, I've got quite a few that we didn't look at last time. CICS region tagging by Darren Beard and Andy Wright. That was in Enterprise Tech Journal issue 3. There was 10 major enhancements to the Zoe Explorer for IBM CICS by Jeff Insaibi. That was back in July. Here's one, troubleshooting WLM missed goals with CICS transaction data, integrated visibility into SMF data, and that's by Todd Haverkost. And then we've got CICS featured toggles by Andy Wright and Darren Beard, and that was in Enterprise Tech Journal issue 2. Okay, as usual, let's look at what's coming next in terms of our presentations. So 15th of November, we've got Ezreal Gross, always popular, and he's talking about Amigamon for CICS on ZOS 5.6 and CICS Performance Analyzer for ZOS next release and features. And that takes us into the new year, so 10th of January 2023. We've got Todd Haverkost, Senior ZOS Performance Consultant at IntelliMagic, and his presentation is entitled New Ways to Analyze CICS Transaction and Statistics Data. So look out for that. And of course, all our meetings are always on a Tuesday. Just to say that if you'd like to co-sponsor the user group, then we'd be pleased to hear from you. And social media. We're on Facebook, there's a link. We're on Twitter, there's a link. And there's also a LinkedIn group. And you'll find all the latest CICS related news there and information about the user group. If you do use Instagram or Twitter or Facebook or any of them, I suppose, the hashtag to use is hashtag virtual CICS. And the YouTube logo is there to show you that the recordings of our most recent presentations are all on YouTube, but the links to it are on our website. Okay, well, that's it for this meeting of the virtual CICS user group. Thank you all very much for attending. Thanks to IntelliMagic and Broadcom for sponsoring our user group and making these meetings possible. And I'd particularly like to thank Russ Teubner and Greg Smith for their presentation today. It was really good. Thanks very much for that. So that's it. Thank you all very much for joining the meeting. And I look forward to seeing you all again on the 15th of November. So thank you all and goodbye.